What is a function family? It's a group of equations that have a similar form, and their graphs all have a similar shape. We have 11 basic families: linear, quadratic, absolute value, square root, cubic, reciprocal, exponential, logarithmic, and sine, cosine, and tangent. There are some others, but these are enough to start with. Now, I know when I said all of these words, that probably brought to mind a certain equation or a certain something about that equation. So let's just look at a family. The family of linear equations. You know what those equations look like. They all have an x or a y or an x and a y, and they do not have exponents. So, you know, when you graph them, you're going to get something that's similar. You're going to get a straight line. It moves around, the slope is different, but it's still a straight line. Now let's look at the quadratic function. Look at the three equations. What do they all have in common? They all have that x squared. That's how you know it's a quadratic equation. Now, what do you know about the graph of that equation? It's going to be a parabola. It's going to move around on your coordinate plane. Some will be skinny, some will be fat, but it's still going to be the parabola. And then let's look at the absolute value real quick. We've been working with this lately. Y is equal to absolute value of x is your parent function, and it gets that V-shaped right there with the vertex at the origin. Now, all of these also have absolute values. They also have the V shape. It's just moved around on the coordinate plane. Now, here's a chart of 12 different base equations, and this is where everything starts. These equations at the bottom of each graph, that's your starting point. So everything else is just going to move it around. When you take the standard form of any equation or family and you combine it with more numbers and or variables, it manipulates that standard graph. And we call these manipulations transformations. There's 4 types of transformations. Rotation spins the graph around the origin, which is the point 0, 0. A translation slides or shifts the graph up or down or diagonally. A dilation stretches or compresses your graph, and a reflection flips the graph over the x or y axis. All right, here's your transformation rules. What's in the middle here is the actual rule, and then over to the right, I put an example of how these affect the absolute value function. So f of x plus h. Now you notice in translations, there's some have h's and some have k's. The h is what you use when there's a number put inside your grouping symbol. The k is a number that is outside the grouping symbol. So let's look at h's first. Adding an h shifts the graph to the left that many units. So x plus 1 inside the absolute value symbols is going to shift that to the left 1 unit. X minus 1 would shift it to the right. Now, if you look at these third and fourth examples, the plus 1 and the minus 1 are on the outside of the absolute value. That's a k, and that shifts up if it's a plus and down if it's minus. All right, on your dilations, this is whether it gets skinnier or fatter. A cannot be equal to 1 because if the number multiplied, and this is a number multiplied outside the grouping symbol, if the number multiplied by that number, by your grouping symbol, is 1, nothing happens. So if it's larger than 1, you're going to get a vertical stretch. That means it's going to get thinner. If the number is less than 1, and that means a fraction, then you're going to get a vertical compression. It's going to press it down, so it's going to broaden out and get wider. Now, your reflection just flips it over your x-axis. Now, let's look at some transformations in action. This is Desmos, and I'm going to show you what happens to this base function. And I started with y is equal to the absolute value of x. So let's watch what happens here as it moves through all these transformations. First, we're going to subtract 3 within the grouping symbol, so that's an h, and it shifted it to the right. Now watch what happens at plus 3. Shifted it to the left. Here's a k, so it's going to shift it down. A plus k shifts it up. Now here's your a at 3. See, it got skinnier. And here's your fraction. See, it got wider. A negative sign flips it upside down. Now here's a combination. This moved it 2 units and 3 units. So you can have more than one combination. Now that's not going to be your problem, is just, restating the rules most of the time. You're actually going to use these as tools. For example, here's 2 problems where you're asked what will be the effect on the parent function of these transformations. Now this first one, your parent function is that f of x equals absolute value of x. That's just your v shape at the 0 origin. Now when you add that minus 3, this is outside your absolute value sign, so this is a k, and it's going to shift this graph down 3 units. All right, let's look at the second one. A negative sign on the outside of your grouping symbol turns your graph upside down. So the first thing is it's going to flip your V upside down. Now a number inside your grouping symbol is an H, so it's going to shift it to the right 4 units. Now you might also be given the parent function and told to use your translation rules to write a new equation that does one of the following. So how would you write a function where you want to translate your absolute value 6 units to the right? Think about it just a second. Okay? Now think about what would you want to do if you translate it 3 units to the right and 4 units down. Think about it just a second and I'll show you the answer. So let's see how you did. First, to translate 6 units to the right, you're going to need an H for that, so that means your number has to go inside your grouping symbol, and it's going to be minus. So f of x equals the absolute value of x minus 6 would translate this graph to the right 6 units. All right, on your second example, f of x is equal to bring it 3 units to the right, you're going to need that minus 3 inside the absolute value sign. Now to go 4 units down, you're going to need a minus 4 at the end, outside the absolute value sign. Okay, so that's basically it. All that's left to do is for you to practice. See you next time.